I want to talk about the slope y-intercept form of a linear relation, but before I do that, I want to talk a little bit about water. Okay, water. Why water? Well, water comes in three forms. We could talk about a solid, a liquid, or a gas. We also have names for water in those forms. We call it ice, water, maybe we call it vapor or steam, something like that. Now the thing to remember about all these forms of water is that they're all water. All of them are water, but they all have different properties. So ice, we know, ice is definitely cold. Steam is hot, and water is somewhere in between. Water and steam, they both take the shape of a container when you fill them in. Ice does not. Ice is not pourable. So I think we all know quite a few things about the different forms of water, but the key thing to remember is that they're all water. Now, if I ask you a question about ice, I say, how cold is ice? But you're holding a glass of water. You say, well, I'm not sure. I'm not sure how cold ice is because I'm holding water. So first let me put it in the freezer, and once it's frozen and it becomes ice, then I can tell you that. Now this might seem like a ridiculous example, but the fact is that linear relations are a lot like that. So for instance, if I say that there's a relationship between y and x, and it looks like this, well, all I'm really saying is that the relation of x to y is that for every y, there are two x's plus 1. So I can state that in this form. I can state that in this form, or I can rearrange it. If you remember from algebra, I could turn it into y minus 2x equals 1, or I could take the 1 over on that side, and I could say, y minus 2x minus 1 equals 0. I could divide everything by y and end up with 1 equals 2x over y plus 1 over y. I could get all kinds of different formulas for this, but the key thing to remember is that they're all the same in the sense that they don't look the same, but they are equivalent. So what equivalent means that if I put an x value in there, if I say x equals 4, and I put that in here, 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 and here, and I solve for y, I will always get the same thing. All these different forms of the relation are equivalent. The thing that's not the same about them is that they all tell me something different. So slope y-intercept form of an equation looks like this: y equals mx plus b. And it always looks like that. It's just one way of writing a relation, but it tells me very specific things about that relation. M tells me the slope, if that relation is graphed, and B tells me the y-intercept. So really, slope y-intercept form of a relation tells me something about that relation when it's graphed. So let's look at an example. Let's say I have y equals 2x minus 3. So let's make a quick graph here. And let's say that we've got a scale like this of 2, 4, 6, and so on. Now, what you may have done before, if I said, look, let's say y equals 2x minus 3, let's graph that. What you may have done before is you may have made a table of values and said, okay, well, when x is 0, I know that it's going to be minus 3. And when x is 1, it's going to be, let's see, 2 times 1 minus 3, it's going to be negative 1. That's one way of doing it. Maybe there is another way. We call this slope y-intercept form for a reason, because it tells us something about the graph of of this relation. And since we can see here that the slope is that coefficient before the x, we know that the slope is going to be 2. So all that means is that how steep is the line going to be? Well, it's going to be a rise of 2 and a run of 1. And there's going to be a y-intercept of -3. So we know a few things about this line. We know that the graph of this line is going to hit the y-intercept at -3, and we know that it's going to have a slope of 2. So it's going to have a rise of 2 and a run of 1, and so on, all the way up. And so it's quite easy to actually graph it when we know this information. And there it is. So that's slope y-intercept form. Now I actually just want to do this in reverse now. So for instance, let's say, we have to erase our graph here. Let's say that I give you a graph and I say, give me the equation for this graph. Well, how am I going to do that, you say? Well, let's draw another scale here. We've got, say, -4, -8, and so on. And so let's say I give you a line that looks something like this. It's going to right here. Okay. Give you that line and I say, find the equation for that line. Well, it's a line, so we know that it's linear. And because it's a linear relation, we can put it in slope y-intercept form. So that's going to look like y equals mx plus b. But wait, we need to put numbers in right here and right here. So let's start fresh. We're going to go y equals something x plus something. Well, the b, which is going to be at the end of the equation, that's the y-intercept. And that's just saying, where does this line intercept the y-axis? Well, we can see right here that it intercepts the y-axis at +4. So it's going to be y equals something x plus 4. Simple as that. It really is. Maybe slightly harder is the slope. Now, so there's a lot of ways that we can figure out slope, but we do know that slope equals rise over run. And if we look at this line, we can see that every time it goes up 3, it seems to go over 1. Up 3 over 1. So maybe it's got a slope of about 3. And another way to test this would be to say we need to look at 2 points that we know for sure on the line and use them to figure out the slope. Well, this point I know for sure. Okay, this point is 0, 4, and this point here I know is going to be -6, -10. So the question is, the rise and the run from here to there. Well, the rise is going to be from -10 to 4 is going to be 14. And the run from -6 to 0 is 6. And we know these are both positive numbers because this is an upward slope. It's a positive slope. So our slope is going to be, once we calculate that, our slope will be 14 over 6, but we can reduce that to 7 over 3. We could also write that down as 2.333333, but 7 over 3 is a little more precise, so we're going to write it that way. And we're done. So you find where it hits the y-intercept, you plug that in for b, you calculate the slope, and there's different ways to do that, and you plug that in for m, and you've got your equation. So in a question like that, you would be done. The last thing I want to try is if I give you the slope, and let's say it's 2/3, and I give you the y-intercept, and it's going to equal -8. Can you graph that line? Well, First of all, it's quite easy to create an equation um, that represents this relation. We could go, y equals 2/3 x subtract 8, right? Because we plugged our b and our m into the equation. But that's not really necessary, actually. So given the slope and the y-intercept, let's graph this. We're going to start with the y-intercept. So our relation intercepts the y-axis at -8. So we're going to make a point there. Let's put that in blue. And we know it has a slope of 2/3, which is going to be 2/3. Now the cool thing about these fraction ones is they're actually giving you the rise and the run right there. So it's a rise of 2 and a run of 3. So it's quite easy actually for me to just go up 2/3. And I don't even need to make more points than that because I can make a line that goes through those two. But let's just do a couple more just to see where this line is going. So between all these points I've gone up 2 and over 3. And actually on this graph I've gone up 4 and over 6, but that's the same slope. So if I draw a line through all of these, I've graphed this information. And it's really as simple as that. You find the y-intercept, you make that dot, and then you do rise over run for one other point, and you can draw it right through. One more example. Okay, one more example. Let's say that m equals a whole number, like 3. And your y-intercept, say it's 6. Well, let's say it's -4. Okay, just like before, we're going to start with our y-intercept. So y-intercept is -4. We make a mark on the graph. But now with a slope like 3, rise over run, well, I've only got one number here. It's not really over anything. All I have to do is go 3/1. Okay, so 3 is the same as 3/1, so I have a rise of 3 and a run of 1. So if I want to graph that, I just go to my y-intercept, and I can go up 3/1. And then up another 3 over another 1. And I can do that all the way. Now the nice thing about this graph is that the scale on my y-axis and on my x-axis are equal. I'm going up by 4s every time. If I was going up by, let's say, 10s on the x-axis and hundreds on the y-axis, I couldn't just count squares for my slope. I'd have to be really careful that I was showing the right slope. But when I have an equal scale on my x and my y-axis, it's pretty easy to do this. And that's it.